Welcome back to Computer Science 4300. Today we're talking all about Assignment 1. So finally, in an intro to game programming class, we start talking about what we actually have to program for our assignments. So today we'll be going over the assignment, how to set up C++ in your development environment for Windows and Linux. If you're a Mac user, I apologize. I've never touched a Mac. So I've written some instructions. It should be easy to set up, but you're kind of on your own for the Mac stuff. But we will also be going over some examples of SFML and the tutorial that they have on their website and how it works and how we can draw basic shapes and stuff like that for the first assignment. So what I have set up here today, and I apologize if this all goes sideways, I have backups in case things don't work. But so this is my actual machine here that you're seeing, just a browser open. But what I've done is I've set up a couple of virtual machines. So here I've got a Windows 10 virtual machine running, and I should be able to just switch over to a Linux virtual machine. Okay, the screensaver is on. That's fine. And I've got that running. Okay, perfect. So I've got my website open in all of them so I can show you what I'm doing for each of the operating systems. Here's Linux running, and now we're back to Windows. Okay, perfect. Cool stuff we can do with OBS that we can't do in a live class, right? Well, we could do it, but it wouldn't be as smooth, I guess. So here on the class website, so if you go to my website and you go to teaching, I've got it zoomed in here a little bit, and you go to 4300, and you come over here to the Google Sheet. Okay, so that's the Google Sheet that we're looking at. And on the Google Sheet, there is a link to the C++/SFML instructions. Because as every developer knows, setting up the environment that you actually develop in is like half the battle, right? So today I got kind of a, not exactly fresh install of Windows, but a fresh enough install of Windows that you should be able to follow along with this video or just follow along with the text instructions to set everything up. In past classes, I haven't actually given out any video instructions, and these examples have just worked. But I just wanted to go through it with you today just to see if everything actually does work, and we can set up everything, you can follow along, and you'll be programming the assignment in no time. So here is the instructions. There are some important links at the top. Here is where you download SFML. So if you take this link and you just open it in a new tab, we are going to be using, now it says here, for Windows, we're going to be using Visual Studio 2019, but the 2017 version is fine. Okay, so you'll be downloading this. And after we go through the Windows instructions, we're going to go through the Linux instructions. And after everything is set up, then we're going to go through the actual assignment. So if you've already got C++ and SFML and stuff set up, I'll have a timestamp down below where you can just skip ahead to the actual explanation of the assignment. Okay, so let's go through these instructions. Here's some links here. There's a tutorial there. We'll be going to that a little bit later. So the Linux instructions and Mac instructions are here, but I want to get through the Windows instructions first. So I'll be going through everything in the Windows instructions except step 1. So go download Microsoft Visual Studio 2019. The community free edition is perfectly fine. So just download the community edition and then install that. That can take up to an hour or two, depending on the speed of your machine and your internet connection. So that's the only thing that I've done here in advance, is actually go through and install that. So this machine has Visual Studio installed already. Second, download the 32-bit version of SFML. So you may have a 64-bit machine, but we are using the 32-bit version of SFML because our programs are going to be compiled to 32-bit Windows. So again, this is Windows instructions only. On Linux, you'll see that this process is actually much easier to set up. Okay, so let's download that. In fact, I've already downloaded that. If I can minimize this window real quick, I've got this folder set up where I have my assignment already downloaded and SFML already downloaded. Okay, so what is the next instruction? Extract SFML to a folder on your computer with no spaces. Now, I know this seems like a little bit archaic, but I highly recommend it because we're going to be setting up Windows environment variables to make things a little bit easier. And it really helps if your Windows environment variables don't have spaces in them. For whatever reason, it interacts poorly with Visual Studio. So what I do with my development is I make a folder on my C drive called libraries. All right, so this is my C drive here on a fairly fresh install of Windows, and I'm just going to go in there and I'm going to extract this SFML. Okay, so let me just double click this SFML. You see in here there's a folder. I don't know who's ever purchased WinRAR, but the free version is fine, and you're just going to drag over or extract the SFML-2-5.1 directory into your libraries directory. Okay, so now we'll close that. So you see here, I say C libraries SFML 2.5.1. Actually, let me go back. I'll change this to a lowercase l, just so there's no confusion with any of that. All right, next what we're going to do is we're going to create a Windows environment variable. And that environment variable is going to be used by Visual Studio to point to the SFML include directory, okay? So this is one thing about Windows, is that once you have Visual Studio all set up and running, it's actually a really nice IDE, but getting it set up can be a little bit of a pain. And because I don't have all of your computers handy, what we're doing is we are setting up an environment variable that you can specify, and then all of my project files that I give you are going to refer to that environment variable. So if you don't have C libraries, blah, 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 this will still work for you. You just have to create this environment variable that points to the directory that you've installed it in. Okay? So what we're going to do is we're going to click the Start menu, and we're going to type env, and that's going to bring up Edit System Environment Variables. Okay, so then we're going to say edit the environment variables for your account. So environment variables, and then user variables for Dave. Okay, so up here, that's what we're going to edit. Then we're going to click New, and the variable name is going to be in all spaces SFML dir, and the value is going to be the directory that we just installed SFML in. So for me, that is C libraries SFML-2.5.1, but for you, it could be on the desktop, it could be in some other folder or a different drive or whatever. But the important thing is that this is where you extracted your SFML directory. Okay. Now it says this step will not work if the environment variable has spaces in it. So that's just the unfortunate thing about this. At least last time I checked, it didn't work, but it's best to just have it in a place that doesn't have spaces. I had this here this is a leftover instruction from when I taught this, and you could do it in the lab, but we're not using the lab this term. You're going to be using your home machines because it's a remote course. So you can just skip step E, just says that doesn't work because you don't have admin privileges. And if you have Visual Studio open at this point, you have to restart it, because Visual Studio reads in all of these environment variables when it starts, okay? So if you've edited the variable while Visual Studio is running, it won't know about that variable until you completely close all the windows and restart it. So assignment 5 says download and extract the assignment zip file from the 4300 website. That's actually a little bit, that's no longer there. So what I'm going to do now is I'm going to update that. So I've got a console window open in another window right now. So we're doing this live, as I said. Link sent to you via email. All right, so now if I go back to the virtual machine, I hit refresh. Now it will say, where are we? All right, download and extract the assignment zip file from the link sent to you via email. So that's the correct thing. So what I've done is I've already downloaded that, and you can put this anywhere, okay? This doesn't have to be in your libraries folder, but I'm just gonna move it over to libraries anyway, and that I'm going to extract. So extract to COMP4300 A1D Churchill. That is going to have your username at the end of it, obviously. Then I'm going to open this up, and you can see that there's a number of files in here now, okay? Once I get to the assignment part, we are going to get to like what all the files are, but I'm just going over the setup right now. So navigate to the Visual Studio folder inside of this folder, the one I just extracted. So let's navigate there and double click the SFML game.sln Visual Studio solution file. And then Visual Studio should launch. So let's double click that and we'll see. So Visual Studio 2019, thank God that worked because I wasn't going to go install that again. This is going to be full screen here. But let's try and get it over to the right-hand side so we can do both. Perfect. So any warnings that might show up, sometimes the very first time you launch Visual Studio, there's going to be a couple of warnings, but we can just ignore those for now. Unless they're like really serious, but as you can see, everything's gone right so far. So now you will need to tell Windows where to find the SFML DLL files by adding them to your path environment variable. Okay, so SFML has some graphics libraries that come with it. What we just did with the previous environment variable was tell where the header files and the CPP files were, okay? But now when you actually go to run your program, you've got to know where the DLL files are. And this step is telling Windows where those DLL files live by putting them in your Windows path directory. And the Windows path directory is where Windows looks up everything that it needs whenever it runs something. So we're going to go back to what we had open. I should have just kept that open. We're going to go, let me move this over to environment variables. And we're going to go to environment variables for our account. So what I'm going to do first is I'm going to copy this value again. So I just have it copied. And now it says, click on the path variable and click edit. So path, we're going to click edit. And then we're going to click new. And we're going to paste. And then type /bin at the end of it. All right. So this, you could hard code this. Or what we can do is type sfml dir /bin. And what this does is it says, okay, there's another environment variable somewhere defined that's called sfml_dir. So we're going to use that, right? So this is, if you did this on your own machine, that will work, or you can hard code it, but let's just leave it as sfml dir in case you want to change it later. So that's what that has done. It's added it to our path. There we go. So now we can just click OK, and we can click OK. And since that was an environment variable, that was, I know I said you had to restart Visual Studio, but that was more of a Windows thing so that when you go to run the program, Windows knows where the stuff is. But all the stuff that Visual Studio needs to run is already fine. So in Visual Studio, switch from debug to release, and I'll get into what the differences between those two things are later. But essentially, debug mode is useful for debugging, but it's much slower. So we're going to come up here. I've got my UI zoomed in a little bit, so it's kind of cut off here. Yours might be a little bit smaller. But I'm going to click release. Okay. And then it says switch from debug to release, and then right-click the SFML game project and click build. So this is the project over here within the solution file. And I'm going to right-click, and I'm going to click build. And now the output down here, if I've done everything correctly, cool. Build, 1 succeeded, 0 failed. If you see 1 failed, that will mean that we tried to compile one project and it failed. However, I just did everything and it worked. So if you're following along and you've done everything with me up until this point, it should be fine. And now we could actually run the project and see what it does, but we're going to get to that when I get into assignment 1. As long as you've gotten that far, that should be fine. Actually, let me just try and run it. So let's click on local Windows debugger. All right. So this is good. The code execution cannot proceed because SFML graphics-2 was not found. Reinstalling the program may fix this problem. So it's good that I went over this. So let me just check something real quick. So I'm going to go back into my folder here. I'm going to go to C, Libraries, SFML251, bin. So that's what we added to our path directory. So that should be fine. I'm going to go into my assignment to see where my SFML game executable is. And if I double click it here, okay. So that worked. So I apologize. You do actually have to restart Visual Studio after doing that second one. So all of you should have gotten that error. Now I'm going to rerun the SFML game and relaunch this. And now it works. Okay, so I did have to restart that. Like, it's been years since I set up Visual Studio and these projects, so I apologize for that little snafu, but now we at least know that it works. Perfect. So we did have to do that. Let's get back to the instructions, because there's a few more things here. If everything was successful, no errors should pop up. To compile and run in one click, click Local Windows Debugger at the top of Visual Studio. And so that when I click this Local Windows Debugger, that will recompile the entire program if anything changed, and then run the program. So your workflow in Visual Studio is basically going to be edit a file, click that button. Okay. So common Windows errors. So if it says that sfml/graphics.hpp not found, then you didn't do step 4 correctly. Okay. So step 4 up here was creating the Windows environment variable to show Visual Studio where your libraries were. So you didn't do that correctly if you got this. Or you may not have restarted Visual Studio. If it says DLL not found, then you didn't do step 9 correctly. So let me just change this. So what I am doing here is I am just, I'll show you, I am editing these instructions. So G, you may need to restart Visual Studio after this step. If it says DLL not found when you try to run your program. Okay, I don't know why it's just inserting new lines here like this. And this should be, you didn't do step 9 correctly. Perfect. So now we go back to our virtual machine where we are reading this, and we refresh, and now this is all better. Perfect. If it says it couldn't find Windows SDK versions, so this happened with previous versions of Visual Studio and shouldn't happen to you. But if for some reason this does happen, you can go to SFML game, Properties, General, Windows SDK version. And so in Visual Studio 2019, there's an option here to just use the latest version. But in previous versions, sometimes you would have to manually select the latest version. And so you shouldn't have to do that, but I don't know, if for whatever reason you encounter that, then that's how you would fix it. Okay, so that's how you set it up for Windows. It should all be up and running after that, and the only thing that I didn't show was how you install Visual Studio, because that just takes a long time. So now let's go over here. I have Ubuntu installed, and I'm going to see if it works as smoothly for Ubuntu. So I'm going to go back here to my website, which I've loaded in Ubuntu. We'll go back to the Google Sheet, and we will go to the SFML setup instructions. Perfect. Okay. So now it says, let me see if I can I resize this window a little bit? Perfect. So it's going to say install GCC and SFML on your system. So there's a few things that you're going to need installed in Ubuntu in order to install this. And of course, to install things in Ubuntu, you're going to say sudo apt-get install and the things that you want installed. However, I've included all the things on one line here. So you're going to need G++, that's the compiler that I recommend using, is the GNU C++ compiler. Then in order to use make, I've included a make file that should work. We're about to test that. In order to use make, we need build essential. And in order to use SFML, we need libsml-dev. Okay, so you can install all of those by just taking this line and pasting it. And now you type in your password, and it should install all of those things. Okay, so I already had those things installed. So it says G++ is already at the newest version, Build Essential is already at the newest version, and libSML SFML dev is already at the newest version. So apparently I had set this up at some point already. And now what I'm going to do is going to the next step. So download and extract the assignment zip file. So I've already downloaded the assignment here. You can see it inside my folder. I've got this COMP4300. So I'm going to unzip that file, COMP4300, and can I extract that to something called A1? No, I can't. Okay. So I'm just going to extract it here because I'm not very good with the manual extraction. So all the files, including the zip file, are there now. Now it says navigate to the assignment root directory. So I'm in the current root directory where actually, let me move that. So I'm going to make a directory called A1. And I'm going to move star to A1. Perfect. So now I've got everything in A1. So it says navigate to the assignment root directory. So I'm going to go cd A1. I'm going to remove that zip file. So you can see here all the files in the assignment. Now you still get the Visual Studio files in Linux, but you're just not going to use them, okay? So there's a couple of different ways that you can compile your program here. The first way is you can compile everything in one step with this very long G++ command. So what it says, if we look, we have a source directory. That's where all the source files are. We have a bin directory. That's where all the binary files are going to go. And that's where all the assets live. So this command says, hey, G++, compile all of the CPP files in the source file, include the source directory. Oh, this is a bit, I don't need that. So that's a typo. So let me remove that. That's from a previous course where we used a little bit of JSON. So I'll just get rid of that instruction. Okay. As I said, by going through everything, I find all the errors. Okay, so that's no longer there. Then we're going to say /standard equals C++17. So we want to use the C++17 functionality. Then it says the output binary file is going in the bin directory, and it's going to be called SFML. Then I want to include all of the SFML graphics, Windows, system, and audio libraries. So you should be able to type this one command when you're in the A1 directory, and it should compile. Perfect. It did compile. So now if I go into, or it also says that what I can do is the included make file, I can just type make, and make will do it all for me, okay? So I highly recommend using the make file, especially for the later assignments, because I'll show what the make file does in a little bit, but let me continue on with this. This will produce the executable SFML inside of the bin directory. Okay, so now we're going to go into the bin directory, and we're going to see what's in here. Okie doke. So actually, the make file produces something called SFML game, and the manual command is SFML. So what I will do, I will just change, you can run either of them, it doesn't matter. But just realize if you use the make file, it's going to output SFML game. If you use the single command, it's going to output SFML. But what I can do is I can just go change the instructions, right? So what I can do now is just change this. And then if I go back and I reload this file, now it, one second, I gotta change one more instruction. This will put the executable SFML game inside your directory. Perfect. So I just changed everything to SFML game. So it says -o bin SFML game. This will put it in there. And then of course there's one more thing that I need to change, which is the executable that you run at the very end is SFML game. Perfect. And then what we're going to do is we're going to cd into bin. So cd bin, or I'm already in the bin directory. And then I can type /./SFML game, and this should run the assignment. Cool. So it worked. I can't believe that all worked. I did not practice that because I didn't want to have to install and uninstall everything. So that worked beautifully for Windows using Visual Studio and for Linux using G++. Now, I have been told by people in the past that if you install G++ and Build Essentials and SFML on a Mac, and then start with the Linux instructions after that. So it's brew install SFML instead of all this stuff. You use brew to install it. Then I have been told that this all works on a Mac, just the exact same way as with Linux. It worked with the Clang, and so this is the last reported version, so this or later should work. So you can use Clang or you can use G++. I just do not have a Mac, so I can't run a virtual machine to show you how to install that. But all the code we will write in this entire class is completely platform independent. So the same game will run on Windows, Mac, or Linux, and those are the setup instructions. If you do have Mac setup errors, please highly recommend that you post in the Discord channel under the course general chat, okay? And then other people who have Mac can help you debug it, and I highly recommend doing that and helping out your fellow students because I am not able to help set up the Mac stuff. Cool, so that all worked. So now what we're going to do is we are going to look at the assignment itself. So what I have done is so I'm in the virtual machine here. I'm going to leave the virtual machine now so that I can go back to my machine where it's a little bit easier for me to look at the assignment stuff. So let me just open that up real quick. And I'm over in the assignment. Okay. Readme.txt. Perfect. Okay. So now starts the lecture part about the assignment now that we're done up with the setting up of C++ on all the different systems. So for assignment 1, there's going to be a couple of different things that you have to do. And if you see inside your directory, so that you took the zip file, you extracted it, there is a readme.txt file. So in this course, I've got pretty detailed readme.txt files where it says exactly what you have to do for this course. So we're just going to read through this. And then once I've read through it, we're going to go through the code inside the assignment. And once we're done with that, I'm going to give you some examples of C++ and SFML working together, which will be the very bedrock foundation of the game engine that we're going to be making for this course. So note, and these notes are just for students in the course. So you will be required to submit main.cpp and no other files for this assignment. Submission will take place on D2L's Assignment 1 Dropbox. So we've got a D2L system for the university. You're going to log in, you're going to go to Assignment 1, and you're going to submit main.cpp only for that. Only one student from each of the group should submit the assignment, okay? And I'll get into that in a sec. So if we look here behind me, your assignment is going to come with a header file at the top of main.cpp. And in here, this is a place where you can enter both of the student names from your group. And so the marker for the course will see, okay, this, it was this student and this other student working on this assignment, and they will put in the marks for both of you. You don't need to email me with your partner name. You both don't submit the assignment. Just one of you submits the assignment, and it really doesn't matter who submits that assignment. Okay. Working solutions are included with the assignment so that you can see what a correct solution looks like. These executables are located in the bin directory and are provided for the lab, Linux, and Windows. So since this course moved online, I have only provided the Windows solution because you can just look at the lecture recording now and see what the actual solution looks like. So I have not provided Mac or Linux executables because I would need to compile like 20 different executables for all the different versions of Linux and stuff, and I'm just not doing that. So you can just watch the lecture to see what the working solution looks like, or you can use the included Windows executable solution if you want to. Now this is very important, okay? And I know you're all going to roll your eyes and say, we're all adults, why is he saying this? It's because statistically, in every single class, at least 5 of you are going to not listen to the instructions. And you're going to submit more than just main.cpp. Please, please, only submit main.cpp and no other files via D2L. we've got 60-something students in this course, okay? And we have a script that takes all the files from D2L, extracts them to a directory, and renames them and runs them so it's easy to mark. If you start messing with that system, you're going to lose marks, okay? Because a big part of computer science is the packaging of the deliverable that you give to your client. In this case, you are the developer for assignment 1, I am the client. The client is paying you in marks for the deliverable of main.cpp. And if you deliver something other than that, then you lose marks, okay? I know it sounds very pedantic, but it saves us hours and hours of effort if we're able to just get this file. So do not zip up main.cpp and submit that file. Don't do that. Do not copy the contents of main.cpp into a Word document and then submit that. I've had 2 people do that. Mind-blowing. Do not submit main.cpp with a project file for an IDE. I don't care what project file you used. You are only submitting main.cpp and no other files. And I know that this is kind of a meme at this point, but there are still some of you who won't do that, okay? And shame on you. You are going to lose at least 10% of the assignment if you submit anything other than just main.cpp. You must include the following info at the top of main.cpp. Both students' full names, CS usernames, and student numbers. So again, over here, where it says group members, you'll enter in the group information about both members. If you did not get a specific feature to work, such as text centering, for example, please explain what you tried to do to get it to work, and we're going to give you partial marks. So yes, I'm a pedantic jerk about things like main.cpp, but if you put in the effort, I'm actually quite an easy marker, okay? So if you couldn't get something to work, just go up here and make a comment and say, we didn't get this thing to work because of X, Y, Z, and we tried ABC. Okay, so if you put that there, we will read it and we can give you marks for that. Not full marks, of course, but at least partial marks to show that you put in the effort and you tried your best. All right, so now that we've gotten that out of the way, I don't need to read that for future assignments, right? Because that's going to be the same for every assignment. Well, almost the same. More future assignments will have more files. Here's the program specification. In this assignment, you will be writing a C++ and SFML program which will read descriptions of shapes from a configuration file, and then drawing those shapes to the screen. Each shape will have a name, position, speed, color, as well as properties unique to each shape type. For example, a rectangle will have a width and a height, and a circle will have a radius. For this assignment, the position of a shape refers to the SFML default of the upper left corner of the shape. And I'll show a working example in a second. You are also required to make these shapes bounce off the side of the window which contains them. This means that if the shape's left side hits the left side of the window, its X speed reverses. If the top of the shape hits the top of the window, its Y speed reverses. Similarly, if it hits the right side or the bottom side of the window. So that means the top hits the top, the bottom hits the bottom. You can assume that all shapes will always be configured to start entirely within the window, and you won't need to worry about what happens if they start outside the window. Each shape's name should be drawn on the exact center of the shape in the given font size and color specified in the file. So just as a note, that last part may be the trickiest part of the assignment. You will not lose many marks if it's not the exact center. Each line of the configuration file specifies one of the config settings of the assignment program, with the first string in each line being the type of setting that the rest of the line will specify. Lines in the config file can be one of the following types, and the lines can appear in any order in the file. So I'm not going to get into that just yet. What I want to do is go back and look at the solution. So here what we have is the config file that comes with the assignment. And we are driving home data-driven programming from assignment 1 in this course, where all of our parameters, all of our settings are always going to be in configuration files and not hard-coded in our program, okay? So, for example, we've got some things here like the window. So the window is going to have a specific size. we've got a font that we're going to be loading, and the color of that font and the size of that font. We've got different shapes. Well, in this assignment, we've just got circles and we've got rectangles, but you're going to read in all of this data, then create the required behavior. And if we look, here is the running solution for this file. Actually, I want to show you that I've got this full screened. Where is that? Game capture? No. Here we go. All right, so I just full screen that, but you can see that 800 by 600 on my monitor is not very big, okay? So this is what that config file specifies. And I'll get into the exact details later, but you can see here, all of the shapes are bouncing off the walls, and they are going at various speeds, and all of that stuff is all in the configuration file. Now you say, Dave, this is a programming class, like, why are we doing this? This is bullshit. But a lot of people haven't used C++ before. They've never done any game programming. They may not be familiar with concepts such as RGB colors, all that sort of thing. And so this assignment is 100% just get Visual Studio up and running, get your makefile up and running, be able to compile the program, and do a relatively easy programming and file reading task, okay? And the next assignment is where we actually start to make a game that's actually really fun. So this is what your program should look like when it's working properly. And if I go back here and I look at the config file, that's not the config file. This is the config file. So I had a big blue circle, okay? So that blue circle, the last three values just happen to be RGB. So I could change the B to 0 and the R to 255 and then rerun it. And now my big blue circle, oops, I did that improperly. Where did I do that? Oh yeah, so this one is 255 and this one is 0. And now I rerun it. Yeah, so now my big blue circle is actually red, okay? So you should be able to just edit the config file and then rerun the program and you see the changes in your file. And that's what we want. If we ever want to change the properties of things in our game, we don't want to ever have to recompile that, because if you're working on real games, it might take hours to recompile the whole code base. So we're going with data-driven design for this one. So let me change that back so that it's blue again, and then we'll go actually into the assignment code. Okay, okie dokie. So once you have, you open up your assignment in Visual Studio, over here on the right-hand side of Visual Studio, these are all the files that are in the Visual Studio project. So you can see over here that Visual Studio has a solution, and then it has projects. So solutions consist of one or more projects. In this course, all of our solutions will only contain one project, because that's all we're really concerned with. So you can just think of a solution as a container for projects, and then you open the solution inside Visual Studio. All right, so the SFML game project, before we get into it, we'll just look at Visual Studio's properties. So up here, Visual Studio things have a number of properties, and all of those properties, for example, like compilation settings, where is the current working directory when we run a program, C++ compiler settings, all that kind of stuff is all done through this user interface. It can be quite complex, but for example, just one thing that I want to show here is like, how would we specify the name of the executable that's produced when we actually compile our program? Well, that is here over in the general settings. So if I go to general settings, over here, it says output directory. So the output directory here, it says .. bin, which means go up one directory and go into the bin directory. The reason it has to go ... is because the Visual Studio project lives in that Visual Studio folder. So we have to go up one folder to the root directory and then into the bin directory. So that is the output directory. There's also an intermediate directory. What that means is that's where all the Visual Studio object files go before they're linked together to form your executable. And then there's the target name. So the target name, that's going to be the application name that gets output. And we've just specified that the target name should be project name. And the project name is SFML game. So if I come in here and I right click and compile or build. Well, I need to switch to release mode first. If I right click and build, that will build that properly. And let me go over real quick into the folder where that is. Oh, I'm not sure that I have this set up correctly. Just give me 1 second. Some behind the scenes stuff here. So 4300. Okay, I'm just opening things up again. That is the files. 1 second here. Okay, this should be fine. Actually, let me go back to the virtual machine and show you there. Okay, so where this stuff goes, in my assignment file, here is the bin directory, and now you can see that it comes with 2 files. When you've freshly extracted this zip file, it's going to come with the solution file that I can run, okay? And that reads in the config file that's included. But when I actually compile my program here, let's just do it in the virtual machine. Why not? It seems to work. When I compile in release mode, so you can see here in the properties, for release, my target name is just project name, so that's SFML game, and so SFML game.exe will be produced. If I switch to debug mode and then look at the properties of debug mode, okay, so I switch to debug, then the target name is project name _ d.exe. So let me just build in debug mode, and that will be built out. And then you can see here, out in my bin directory, I've got SFML game _ d.exe. Now, there's a couple of other files that get output here. They are for debugging purposes. It's like the debug symbol lookup table that Visual Studio uses. You don't have to worry about those. So that is, that's that. Let me open up the file again. Uh-oh, where'd my mouse cursor go? Uh-oh, I closed it. Okay, we'll go back to the main monitor here then. Sorry, my virtual machine just took over my my mouse for a second. All right, so let's look through, now that we've gone over a few of the Visual Studio settings, like the really basic ones, to show you what's going on. All right, so the first thing we do in our actual program, let me make this just a little bit bigger to give you as much reading space as possible. So there's only one file, there's only main.cpp in this project, and in future projects, we will have far more files than this, okay? We'll have like files per class and all that kind of stuff like you would in a Java program. The first thing we do in our program is we're going to include sfml/graphics.hpp. That is the header that allows us to use SFML's graphics functionality. Then we're going to include IO stream, and what you might have to do for this assignment is include fstream, because like I did in the previous assignments or in the previous lectures, I used fstream to read data from a file. Okay, so let me just once again run this version of the program. And you can see here that, okay, this doesn't look like the assignment at all. All it is a green circle moving slowly up to the left with some sample text down here. And then, oh, it doesn't even collide, right? So this is obvious. This is what I give you as a template, and it's your job to fill in the rest of the code for this assignment. Okay, so we've only got one function here. You can create as much code or as many functions in this main.cpp file as you want. I'm not limiting you to putting everything in. However, I'm not limiting you to putting everything into main, the main function, but everything does have to be in main.cpp. So for example, if you wanted to have another function up here, right, you can totally do that. You can have any number of functions. You can even write your own classes here if you want. I don't care, however you want to implement the assignment. So the first thing that happens in main is we're going to set up the actual SFML window. Okay, so this says create a new window of size, this is actually 640 by 480 pixels. The top left of the window is 00, and the bottom right is width height. Okay, so that means that SFML works with the top left coordinate as 00 and the bottom right as the maximum of both of those values, so width and height. So I've just created some integers here. Window width, that's going to be 640, and window height, which is 480. Then, in order to set up a new a new SFML window, which we're going to actually draw things to, it's just one simple line of code. So the object type that we're going to be setting up is the SFML render window. And the SFML namespace is SF. So we go SF : render window. We're going to give that the variable name window, and we'll refer to window later. And as the parameter to the window, the render window constructor, there are two arguments here. The first argument is the video mode, and the second argument is the title of the window. So here I've just used the basic SF video mode and given that the width and the height. And what that will do is it just says, here's the video mode. It's a windowed program, so it's not full screen. You can do full screen video modes and stuff. We'll talk about that later in the course. But it's a windowed program that has width and height. And this is just whatever you want to appear in the Windows title. So if I change this to SFML Dave and compile it, then this will say SFML Dave, even though that's a bit small for you to read. Okay. So now what we're going to do, just for the sample code in this assignment, is let's make a circle shape that I want to draw to the screen. So it's really simple. This is why I love using SFML, because it's just a couple of lines of code to do everything that we want. And for example, some people have said, why don't you use OpenGL in this course? Because then this course becomes about pulling your own hair out, trying to code stuff in OpenGL, and you'd be 2 months trying to learn to set up a window in OpenGL. Here, it's just a couple of lines of code in SFML. So if we want to draw a circle, we say SF circle shape, that's the object. Here is the variable name circle, and the constructor just takes in the radius. Okay, so we're going to say this is a circle with a shape radius of 50. And this 50 is in screen pixels, right? All of our measurement is in screen pixels. So then what we want to do is, let's say we want to color the circle green. So we can say circle.setFillColor SF color green. So SF color has a bunch of different hard-coded colors in them. So inside the color variable, or the color class, there's a number of static variables which refer to different colors. But we could also, if we wanted to, change this to manually specify RGB. So RGB color, if we wanted to say something like purple, well, purple is 255 red, 255 blue, RGB. So 255 in red and blue. So if we add red and blue, we get purple. So now we should have a purple circle. Okay, so if we don't want to use the manual colorings, we can just do that. Perfect. And in your assignment, you are going to need to read in specific RGB values and put them in here. Then what we're going to do is we're going to set the position of the circle. So the initial position of the circle is going to be at pixel 300 in the X coordinate and 300 in the Y coordinate. And this just sets the top left position of the circle. Okay, so that is not the center of the circle. That's the top left of the circle. Now, it's actually the top left of the bounding box that defines the circle. So if I print screen this, and then I come over into MS Paint, paste this here. So let me just show you what I mean by that. So we're all doing it live here. So that position, if I draw the minimum bounding box that contains this circle, the position of the circle is the thing that's right here. Okay, so that's right there. So we've got 0, 0 up here and width, height down here. All right, someone asked a good question, which is, why did I specify here 300.0F? What does that mean? Okay, so F specifies that this is a float. 300.0 by default specifies a double precision number. And so if I take these out and I recompile my program, I want to look at the warnings down here that I get. Okay, I didn't get any. Some versions of SFML, sometimes if you pass in a double instead of a float, if you have like super high level warnings turned off, it's going to be like, warning, converting from double to float. Okay, so I just specify everything as a float just in order to get rid of those warnings on some, compilers. And then I want the circle to move a little bit, and so I just specified a move speed. We'll come back to that. Next, I want to draw some text to the screen, okay? And this is where SFML comes in super handy rather than using something like OpenGL. Drawing text in OpenGL is the biggest nightmare of my life. It's absolutely insanely bad. And just for text drawing alone would I use SFML. So here's how we're going to draw a load of font in our program. So first, we've got to have a font somewhere. And so if I switch back here for a second and look at our assignment structure, inside our assignment zip file, we've got the bin directory. And inside the bin directory, we've got fonts, okay? And then I've just included this Arial font, the TrueType font Arial, so that we can load that font and use Arial for drawing in our program. Now, it turns out that Arial is like a megabyte, and I didn't realize that before I created this assignment. So I'm going to replace Arial with a different font in future assignments so that this assignment download is like 30K instead of a megabyte, which is crazy. Now, our program's executable file is going to be running locally to this bin directory. That is where the current working directory of this program is. So if I want to specify the Arial font, it's inside the fonts folder within bin. Now, so I'm going to have a look at that, come back here, and we're going to specify, okay, I want to load a font, so let's first create a font object. Then I'm going to say myfont.loadFromFile, and then I'm going to give it the file name of where my font is, right? So I'm currently in the bin directory, so I need to go into the fonts directory and then load arial.ttf. Now, what does this mean? Okay, what does this whole thing up here? I could have just said myfont.loadFromFile. That's all I had to do. Okay. However, this is a little bit of error handling. So myfont.loadFromFile, this function tries to load the font from a file, but if it fails, then it will return false. So if it loads the font successfully, meaning the file exists and I've loaded it properly, it will return true. If it doesn't return true, then we're going to do something with that. So if this returns false, then I'm saying if not false, right? Which means if true. So if something went wrong with loading that, if we couldn't load the font, print an error to the console and exit. So standard C error, could not load font. So let's just look at what happens if I do that, because this is going to be a common error. So let's change that to Arial 2, just so I'm going to create an error like this, and then I'm going to compile and run my program. Okay, wow, what just happened? That's a little annoying. I should have seen a console, I should have seen an error message, but I didn't see anything. So what we're going to do is, I hope I can find this error. So let's say console, is that where I would find this? General? Okay, so inside tools, options, in search options, let's go to console, and under debugging, general, it says automatically close the console when debugging stops. Okay, so we're going to unclick that and click OK. Now if we run it again, okay, now it says it's going to keep the console of the program open until we hit a button. Okay, so here's the console, and it said failed to load font, fonts/arial2.ttf, failed to create the font face. That was printed out by SFML, and then could not load font is what we printed. So now I'm going to press any button, my console goes away. So if you want to be able to print to the console and debug stuff, right, you may have to turn on that option. Okay, So that's what that is. Next, that's the font, okay? The font is the way that the text will look, but now we actually have to set up a text object. So a text object in SFML is going to be, again, from the SF namespace, and it's going to be a text object. Really simple. So the text object constructor is going to take in 3 values. It's going to be the string that we want to construct. So for example, sample text. Let me change this to Dave's class text, just for something to do. And now the font that that text will be drawn in is going to be my font, which I set up here and loaded Arial, and I'm going to change this back. And then the size of the font in font point size is 24. Okay, so that's kind of big if you know anything about fonts. Then what I want to do is I want to position the top left corner of the text so that the text aligns on the bottom text. What? Let me read that again. Position the top left corner of the text so that the text aligns on the bottom of the window. Okay. Text character size is in pixels, so that 24 is in pixels. So I want to move the text up from the bottom of the screen by its height. So if I just run this program and see what I mean by that, you see down here, the very bottom of the text is on the very bottom of the window. So I want that to happen. So I can do that by setting the text position. So I set the text position with 2 values, the X and the Y. So what I did was I said, okay, I want the X value of the text to be at the very left-hand side of the screen. So that's 0, because it goes from 0 all the way up to width over on the right. And then I want to position it so that the bottom of the characters are resting on the bottom of the screen. So how do I do that? Well, the Y value is going to be equal to the height of the window minus the height of the characters. Really simple. So let's go back and look at that again. So for example, if I made this, instead of the height of the characters, I said minus 100, then my text will be actually like a bit above the bottom of the screen. Right? So that's where my text is now. And if I move this over, say 110 in the X direction, then my text will be over. Perfect. So someone asked, why 100 and not 100F? Yeah, I guess I was a little bit inconsistent with that. So yeah, you don't need to specify the F in the floating point, and I probably won't going forward with the rest of the course. Probably something I typed in one and then someone asked, so I wanted to justify that. Alrighty. So now we get to a very important concept in any sort of graphical program, and that is the concept of the main loop. Okay? So when we run our program, this program it launches a window and then things happen, right? So how does that work? Well, essentially it sets up a window and then it says, what we want to do is, while the program is still running, make some changes to the stuff on the screen and then draw the screen. Then do that so many times per second or with a certain delay. So this program is, if you've ever, played video games, you know about frames per second. Like most games run at 60 frames per second. On old consoles, maybe 30 frames per second, or if your computer's really bad, or if you've got a more modern monitor, maybe 144 frames per second or something like that. So those frames per second, and we'll get more into this in the future, but we're essentially just saying, okay, do these things at a certain rate. So we've got a main loop that just says, while the window is open, do some stuff, okay? Here we've got some event handling. I'm going to come back to the event handling, okay? I'm going to explain that. I know it comes first, but I'm going to come back to that right after this. So what do we want to do in our loop? Well, what we want to do is, if we want our circle to move, we're going to have to probably update the position of that circle, right? And then we want to draw the things back to the screen. So let's look at how we do that. So inside our while true, essentially, we're first going to set the position of the circle. So up here, I had a circle move speed. And that's just essentially going to say how each time this loop runs, each iteration of the loop, how far do I want the circle to move? Okay? in both the X and the Y position. So I'll just say, well, to move the circle, I'm going to set its position to something else, right? So I say circle.setPosition. Now, where do I want to set the circle to? Well, I'm going to set it to its previous position plus some value. So let me spell that out a little bit more verbosely, okay? So I've got an SF vector to F, and that's going to be previous position equals circle.getPosition. Alrighty. So that's the previous position of the circle. If I ever want to know what a shape's position is, I can say circle.getPosition. And if in Visual Studio we mouse over this, we can see, now I know on the stream it's going to be a bit hard, but this returns a const SF vector to F. We will get into vectors, but this is essentially a vector containing two elements, which has an X and a Y. Okay? So I can refer to previous position.x or previous position.y whenever I want to get the X and Y positions. So now what I can do is I want to say SF vector 2F because I want a new position. So I'll say new position equals previous position plus, and well, I want it to move in the X and the Y direction. So, well, let's do this first. Vector 2F move vector, right? So I've got a circle move speed variable, and I want my circle to move in the X and Y coordinates by this value every frame of the game. So I'm going to set up that move vector, and actually I can shorten it like that. I don't need to do what we just did. So SF2 move vector here, and so the new position is going to be equal to the previous position plus the move vector. And down here, I can just set the position equal to new position. I see how that works. So I get the previous position, I say how much I want to move it by, and then I calculate the new position and I put it in here. So let's just see if that worked. It should be moving up and to the left. And the reason it's moving up and to the left is because every frame, it's moving by negative 0.01 in each of those directions. Okay, let's say I only wanted it to move to the left, right? So then, well, I want it to move to the left, but I don't want it to move in the Y direction, so I'll just change that to a 0. There we go. So now it's just moving to the left instead of moving up and left. Gotcha. Then, after we have our circle set, what do we want to do? Well, we do a couple of things. First, we want to clear the window, right? Because I drew some things on the last frame, and I don't want them to be there this frame, so I'm going to clear the window. And as an optional parameter in here, you can put in an SF color, and that color, let's say we wanted it to be red, it's going to clear the screen by drawing this color on top of everything else. So you can see here that we've cleared the screen to be red instead of black. By default, it's going to be black. So if I put nothing in here, then it clears the background of the screen to be 0 or to be black. Then I'm going to draw the circle, and it's really easy. Just window.drawCircle. So that circle variable whose position we just updated, we're going to draw the new version of the circle. Then we're going to draw the text, and then we're going to call window.display. And window.display is just basically the function that you call to tell the screen to draw. Okay, behind the scenes, it does a bunch of other stuff. But essentially what we have here is every time you want to draw on your frame, you want to do your rendering in SFML, you're going to call window.clear, then you're going to draw the things that you want to draw, and then you're going to call window.display. So let me just show you what happens if we don't call window.clear, and let me make it move diagonal again. So then I run it, we did not clear the window, and so whatever was there on the last frame is going to be there on this frame as well. Okay, so that's what happens if you don't clear it. Cool. Okie dokie. Now, it turns out, I want to clear it again. It turns out in this program, by default, what I've given you, if you press the X key, it's going to print something out to the console. You can see key pressed with code equals 23. What the hell does that mean? Well, I'll explain it in a second. And also, look, the direction of my circle, it changes if I press the X key. So the last bit of thing that we need, the last bit of knowledge that we need to write a video game, basically, is how do we interact with the program. So in this assignment, we're just doing some keyboard interaction. And SFML, luckily, has that built in for us. So what we have in here is SFML's event handling system. So every frame of the game, we want to check for events, and those can be mouse clicks or they can be keyboard events, and we want to do something whenever those events happen. So the way we do that is we set up an SF event. We're going to just call that event. And then we say while window.pollEvent event. And essentially what that does is it goes through all the possible events that could happen inside this event. And the events, we poll the window for any events that have happened. We put them into this event container, and then we go through all of the events in that container. So we've got some events, possibly not. If nothing has happened that frame, this code just gets skipped, okay? So there's a few different events that can happen. There's like mouse presses, there's keyboard presses. There's this one, which is SF event close. So that means what triggers close? Well, one thing that triggers close is if we... Sorry, Snake is texting me. I didn't turn off my phone before the lecture. Apologize. So if I hit the X, that sends the SF event to close, okay? So if I go up here and I type standard cout window was closed, and then a couple of new lines, then whenever I close the window, in the console, you'll see that the window was closed. So here's the console, nothing has been printed, I close it, and now we say window was closed, okay? That's how that happens. Now I can delete that again. Here's another type of event. That is the key pressed event. So we just say, if the type of event is a key press event, let's print out the key that was pressed to the console. All right? So let's run it again. And what I'm going to do is I'm going to press some keys. And you can see all the different key codes. So the key codes are just the integer that SFML happens to associate with the key that I pressed, right? Because everything needs to be an integer under the hood. So let's see, if I press A is a 0. If I press B, 1, C, oh look, so we can see a pattern. Sorry, I wanted to see how fast I could type all the keys. So A through Z are the letters, A through Z are 0 through 26. Then if I go, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then like special keys, maybe tilde is 54 or escape is 36 or something like that, okay? So that's what that is, and that's why we've printed them out there. However, if we want something to happen when a specific key is pressed, well, we don't need to remember those like integer codes because SF keyboard contains all of the different letters for us. So in Visual Studio, another reason I really like it is the IntelliSense. So we can come down here and look at all the different keys that SFML has. So for example, if I change this to be, I don't know, F5, for example. So when F5 is pressed, change the circle speed. So let's see if that happens now. F5, right? Key code 89 is changing the direction of my circle. So that's how I would do it. So someone asked there, what about modifiers like shift and control? Well, as I'll show in a little bit, SFML has a great tutorial that will list all the stuff like that. I just want to go over right now the stuff for the assignment. So what happens when we press the X key? Okay. When we press the X key, we want to change the direction of the circle. So what I've done here is I've said circle move speed times equals -1.0. And essentially, that just multiplies the move speed of the X and the Y by -1, which essentially flips the motion. Okay, so that's really easy. So that's it. That's the code for the assignment. However, what you're going to have to do is go through and actually read in the values of things from the text file. Oh, So let's go back and look at that again. Okay, so now that you know the very, very basics of SFML and how the sample code works, let's look at the rest of the README file. So there's a bunch of things in the config file, and I said each line of the configuration file specifies one of the config settings. If I go back and look at that again, I've got my config file right here. So you can see there's things like windows, fonts, circles, rectangles, etc. So let's try and keep both of these open if we can. All right, so let's move this one over here. And we'll have this one right here. Okay, so it's not going to quite work, but we'll see. So one of the things that can be there is one of the lines is window WH. This line declares that the SFML window must be constructed with width W and height H, each of which will be integers. So over here in the config file that I've given, you can see that the window should start 800 by 600. Font. So if you see font, then there's FSRGB that you have to read in. This line defines the font which is to be used to draw text for this program. The format of the line is as follows. So F means the font string, so the font file. S is the size, and the RGB colors follow. So you can see here that I have font, then this string, which shouldn't have spaces in it, but it doesn't. 18 is the font size by default, and then 255, 255, 255, that's the RGB, and that means white. Okay. Then you could have a rectangle defined, and there's a bunch of parameters for the rectangle. So the parameters for the rectangle are N is shape name. Okay, that should actually be N here. Apologies. That's going to be a string. So that's the name. Then there is the initial position of it within the window, which are two floats, and that's X, Y. Then initial speed, which is SX, SY. Then the RGB color, and then the size. Okay. And the size is in width, height. So let's look at the first circle that's defined here. So the first thing that we see, this is a string, and that's going to be the name of the circle that's drawn in the program. Okay, so let me just run the solution. So this can run up here while I'm explaining this. So we've got over here, you see this sea green circle that's going around. So then we've got X and Y, that's the initial position. So the initial position of the initial position of sea green circle when we started the program was at 100, 100. Then we've got the initial speed, SX and SY. So that's the speed in the X and the Y direction. So we see here that that's negative 0.03, so it's going to be starting out moving to the left, and 0.02 in the Y, so it's going to start moving down. So it's going to be going down left when we start. So let me restart it and see if that's true, and we can see sea green is moving down and left, so that's correct. The next thing is the RGB color, so that's these three variables, so that's R, G, and B, and we can see that the G is 255, and of course, you know, the values are going from 0 to 255, so that means full green. And then the last integer here is the size of the radius of the shape in pixels. Oh, sorry, I'm doing rectangle. My apologies. Yeah, so the rectangle is almost the same as a circle. Instead of a radius, it has a width and a height at the end. So apologies, I was looking at the circle first, but rectangles are essentially the same thing. The only difference between a rectangle and a circle is that a circle is going to have just R, the radius at the end, and a rectangle is going to have a width and a height. So I was looking at a circle, but explaining the rectangle. Okay, so that's it. That's what you have to read in, and you're going to read that in using the stuff that I did in assignment 2. So here's some hints for the assignment. In order to store an arbitrary number of shapes from the configuration file, you must store them in a container. A standard vector is recommended. So over here in the default config file, I've got 3 circles and 3 rectangles. I could pass you in 10 of each, or 100 of each, or 20 of one and 2 of another, or none. okay? And we will have sample configuration files that we run your program with. And so you can't just assume that there's going to be, this is the only config file we're going to use. So you have to use some sort of container. I highly recommend a vector to store these things in. All right, so another thing, a shape will touch the sides of the window if its bounding box makes contact with it. Each of the shape's bounding rectangles can be obtained via, and what do I mean by bounding rectangle? This is the bounding rectangle, okay? So when I say shape.getLocalBounds, that's the way we get the size of this. That will give us, for a circle, it will give us the square or the rectangle that contains that circle. Or for a rectangle, it will just give us the rectangle because they're both equal. So shape.getLocalBounds has a top, a left, a width, and a height. This gives the local position of the top left of the rectangle. Local pos means it is relative to shape.getPosition, not the window, as well as the width and height size of the rectangle. So what this means is, if I have this right here, so since the position, let's say the position of this circle, if I can make this a bit less big. Let's say this circle was at 100 in the x direction and 75 in the y direction, okay? That's the position of the circle. If I say get local bounds top and left, that's actually going to return 0, 0. And the reason for 0, 0 is because it's local to 175. It's local to its current value. If I say, what's the other ones? There's width and height. So the width of this circle will be twice the radius of the circle. So if the radius was 50, it's going to be 100. And then the height similarly is 50, or is 100 if the radius was 50. I think there's also get global bounds, and global bounds will give you the position of it with respect to the window rather than respect to the shape. But the whole point of this is that you need to know how big the shape is in combination with its position in order to measure the distance, right, from the screen. So if this position of the left-hand side is ever less than 0, then that's a bounce on the left. If this distance from the right to the right-hand side of the screen is ever less than 0, then, or if the right-hand side of the object's x-coordinate is greater than the width, then that is, that's another collision, right? That's a collision with the right-hand side of the screen. So that's what you're going to have to do in this assignment. Okay. Similarly, so that's the how you get the bounds. And similarly, an SF text elements bounding box rectangle can also be retrieved via text.getLocalBounds. So what that means is that the text is going to have this rectangle as well. So down here, the rectangle which perfectly contains the text, that's how you get that as well. You'll have this getLocalBounds, okay? Please use C++ file reading. So standard IF stream makes that easy rather than C-style file reading. If I see people do file star equals F open, you're losing marks for that because this is a C++ course and not a C course, okay? I see a couple of questions. I'll get to those in a bit. One thing that I want is, let's say I have a circle here that looks like this, and I have some text, like this is the shape name. Then what I want is I want that shape name centered perfectly within this circle, okay? So that means that if I draw a line from the top of the circle to the bottom, and a line from the left of the circle to the across, where those lines meet is the exact center of that text. Not the bottom, not the top, but the exact center of that text, okay? That's how you get exactly full marks for this assignment. All right, that is pretty much it for the assignment side of things. I had a question in the chat. So let's see. Not sure if this was mentioned, but can we assume that the window and font lines will be the first two lines always? No. Now, I may have assumed that in my solution. Okay, so, all right, how about we say this? The window and font will be the first 2 lines, but this can be anything. It could be circle, rectangle, circle, rectangle, circle, rectangle. All right. So yeah, okay, just why not? Let's make this, these will be the first 2 lines in all the config files, and these can be in any order, just to make your life a little bit easier. All right. Someone had a couple more questions. Okay, I'll get to the tutorial for SFML. We're not going to go too much later, but I do want to go over just a quick couple of things. If you ever need help with SFML, then if you go to, if you just Google SFML tutorial, or you go to the instructions and you have the tutorial here, you can just go to this, and it's really a truly excellent tutorial, okay? So if you have, please, the only thing I ask is not to use this, because my setup instructions are going to be vastly different from the setup instructions of SFML, because they're creating like a new Visual Studio project file and importing CPP files and stuff. Don't do that. Please use the project file that I gave you and it'll make your life much, much easier, especially in the future when we have multiple files. So don't look at this getting started part, because we've already done that, okay? Skip that. We'll get back to time and stuff. However, we will look at a bit of the window stuff. So if you want to know, for example, maybe how do I do full screen? Or how do I do keyboard and mouse and stuff like that? Well, in here, they go through, how do I open a window? Well, here's how you open a window. How do I resize the window? How do I make it full screen? There's all sorts of really excellent tutorials for SFML in the website. It tells you about like what the main loop is. It tells you about how events are polled, and it really reads like really great in English from top to bottom. So as we go through with the course and you want to do more stuff like setting the size of the window or the position or whatever, you can go through this tutorial. Here it is. Here's how to handle keyboard events, mouse events. We're going to be doing a lot of stuff with mouse events in assignment 2, so we'll come back to that stuff. You can also do like keyboard or controller or joystick inputs. Down here, we're going to have like drawing sprites and loading PNG files, and all of that stuff is going to come with future assignments. And we're going to go through textures and entities and all that kind of stuff in future things. But I did want to show you that if you ever have a question about SFML, first, go to the tutorial, okay? And second, go to the Discord. Second, Google it. So if you can't find it in the tutorial, then you Google it. If you can't Google it, then you go to the Discord. And if no one can answer for you in the Discord, then you send me a message, okay? So I'm like the 4th line of defense for asking questions. Please, and I've seen this happen like many times in courses that I've done, is people will send me a message on Discord with a question, and then 3 minutes later say, never mind, I found the answer, okay? Someone out there is asking for the link to the Discord. The link to the Discord is for students only. Okay, so I will not post the link to the Discord in here. However, the link for students will be on D2L in one of those announcements, okay? If the link to the Discord server has expired, because it's a new link every week, then please tell me that the link has expired and I will post a new one, okay? Just send me an email. Don't message me on D2L, because I never read that stuff because the messaging system is terrible. Send me an email and say that the link has expired and I'll post a new link on D2L. But yeah, I just can't have randoms flooding my Discord with troll messages and stuff like that. And at the very end, we'll get into audio and all sorts of things. Cool. So that is how you set up everything. And the setup is going to be the exact same thing for all future assignments. So all future assignments are going to have the exact same structure, where there'll be a bin, source, and Visual Studio directory. Every single assignment, you'll just, now that you have it set up, you don't have to do the setup anymore. So you'll just download the assignment file, you'll double click the Visual Studio solution file, and you'll just get started programming with your assignment. And when we start to get into like multiple files and stuff for assignment 2, then I'll get into some more of the Visual Studio settings and stuff like that that you may want to play around with. Oh yeah, one last thing before I go, I did want to mention Visual Studio's debug mode. Okay, so debug mode in Visual Studio is quite excellent. So let's do something that makes a program crash. All right, so here I'm going to say for int I equals 0. Let's say I have standard. What's something that's gonna crash for me? I don't need something that crashes. I'm just going to do an example. Int I equals 0, I less than 100, I plus plus. We are going to print out I. Okay? We're going to standard, cout, I, and a new line. All right, so let's run this program. You're going to see in the background a bunch of stuff print out. Okay, so it printed 1 to 100, and I've still got my program running, but let's just pretend that we return after this. This has nothing to do with the assignment, by the way. This is just a Visual Studio thing, but I wanted to show you how powerful this is. All right, so Visual Studio has a debugger built into it. So I can come up here into Release and click Debug. Now, if I just click Run, this needs to return a value. If I just click Run, it will compile and run the program in debug mode. Okay, so debug mode is going to be vastly slower than release mode. So debug mode turns on a bunch of memory mapping stuff. It's much, much slower. So I highly recommend what you do for the assignments is develop in debug mode and then run your program in, once you've got all the bugs worked out, compile it into release mode, and then that'll be like the full speed working version of your game. So if like assignment 2, assignment 3, you start to have a really slow running game, it's probably because you have it in debug mode. All right, so what can debug mode do for us? Let's say I want to have some integer value a, and I'm going to set that equal to 10, and I'm going to say a plus equals I. And then let's print out a here instead of I. So a is going to start at 10, I is going to loop through, and we're going to add I to a. So we'll run that again. Okay, perfect. So that printed out a bunch of numbers. Now let's say that we wanted to step through our program and see what happened. What we're going to do, if you've never used a debugger before in Visual Studio, in order to set a breakpoint, you just click over here in the gray area to the left of the line number. Now what's going to happen is when I run my program, it's going to stop at that line of code. So I'm going to click Local Debugger. Now it comes back to the program, okay? So it comes back to the program, and now what I can do is I have controls up here. I have step into, step over, and step out. Step into means if this line of code is going to be calling a function, I can step into that function. Otherwise, I'm just going to step over. So I'm going to step over this line of code, which will execute that current line of code. So if I look down here at these values, and I apologize if this is a bit small, but you can see down here, all of these values down here are the local variables that I have in my program. And you can see here, before this line of code executes, the value of a is equal to -8 million or something like that. Why is that? Well, it's because that value of a has not been assigned before this line of code runs. It's just whatever happens to be in RAM. We talked about how unsafe C++ can be. So now I'll step over that line of code. That line of code has been executed. We're now on this line of code where the arrow is. And you can see now that a is equal to 10 because I've assigned that value. So currently I doesn't have a value either, right? Because it hasn't been assigned yet. So let's step over this part of the loop, and we can now see that I has a value of 0, right? So now we're on this line of code, and if we want to see what a is, we can just mouse over a. So I know this is really small because of the font that Visual Studio uses, but I can mouse over variables to see their values. So currently I is 0, currently a is 10. So I mouse over a, it's 10, I'm on this line of code. So now this addition is going to happen, right? So I gets added to a, but look, a is still 10 because 0 has been added to 10. Now, if I step over again and I go back to my console, you can see that I printed out 10. Okay? So I step over again, it goes back to here, right? And now I is now equal to 1, and then I add it to A, so A is now equal to 11, and then I print out A, right? So this debugger, I'm not going to go in too much into it, but it lets you step through line by line through your program in case you have any errors or you want to see exactly what's happening. So down here, 11 should be printed. So what should the next number be printed? Here's your pop quiz for the chat. What should the next number be printed to the screen? Perfect. Okay, a bunch of fourth year students could figure it out. So I'm going to go back up. I is now 2, A is 11, adding 2 to 11, print it out, and now we've got 13 on screen. All right, great. Now, let's look at an example in our game, okay? So I'll take that out. Now let's put a breakpoint down inside the loop, the main loop for our program. So I'm going to run it again. Now our window popped up, but nothing has happened yet because it hasn't been rendered yet, okay? So what I can do now is I want to say, okay, let's see that circle. So if I want to see the circle position, I can mouse over circle, and I can see the radius of the circle is 50, and the point count, okay, the point count is actually how it gets drawn. So the radius of that circle is 50, the circle move speed is like negative 0.01. Now I'm going to go down through the program. There were no events of the types that I wanted, so it's going to go back up through, and now I'm going to get down to previous position. You can see the calculations for that. And now before I set the position of circle, it'll have some position, and then after I set it, you can go through and debug all these positions, okay? The position is now 299.9, 299.9, because we subtracted 0.01 from each of them. So you can go through, and this is such a powerful debugging tool. You have no idea. This is going to save your ass multiple times during the course. So that's just a taste of the Visual Studio Debugger. Perfect. All right, so the next class, that was assignment 1 and a bit about SFML. Next class, we're going to start the real meat of this course, which is learning the entity component system and how we're going to implement that for the rest of the course. And then all of the rest of our games are going to be actual games that we implement using ECS, C++, and SFML. Thank you so much for watching, and I'll see you in the next one.